Hi everyone, myself Professor Shilpa Patil, working as an assistant professor in the Department of Electrical and Electronics Engineering, SAVI with the Institute of Technology, Bangalore. In this video lecture, we are going to study about principles of combinational logic. So, in this lecture, the following topics will be discussed. First, we are going to study about what is a combinational circuit and its block diagram. Then we are going to study about the types of Boolean expressions. Then these Boolean expressions are represented in a standard forms that is a canonical forms. So by the end of this video, we will be able to convert any given Boolean expression into an canonical form. So in a basic electronics, that is in chemistry cycle, you already studied what is an digital circuit and the logic gates and its truth table, everything. So what is a digital circuit? A digital circuit is a circuit which accepts the signals in a two discrete levels. Either it may be a logic 0 or 1. Such digital circuits are maybe of two types. One is a combinational logic circuit and another one is a sequential logic circuit. So in digital system design subject, so module 1 and 2 will be you are studying about a combinational logic circuit uh, and its design. Whereas in a further modules, you will study about the sequential logic circuits. So what is a combinational logic circuit? So the combinational logic circuit is a circuit whose output depends only upon the present input. That is, if suppose I consider this circuit, right? This is a combination of three logic gates, NOT, OR, and AND. So if I give an input to this gates, so if I give 0 input to the NOT gate and 1 to the OR gate, so the output of the NOT gate is 1 and the output of the OR gate is 1. Then the input to the AND gate is 1, so the output will be 1. So here I have taken the output variable as y. So the output I got it as 1 for an input combination of 0, 1, 1. Suppose if I change any input here, so if I change an input to the NOT gate as 1, so the output of the NOT gate will be 0. Then the output of AND gate, I'll get it as 0. Means the output of this circuit will become 0, right? So what we can observe here, whenever I change an input, I'm getting an output with respect to that input, right? We are not taking consideration of any past input and output. Means we don't have any feedback part to fed off this output to an input, right? So in this circuit, we are getting an output only with respect to the present input, not on any past history. So such circuits, we call it as a combinational logic circuit, right? And since it doesn't depend upon any past history, we don't have any memory elements in a combinational logic circuit. Whereas in a sequential logic circuit, so the output is depends upon present and the past history. Okay, in detail we will study in module 3, right? So this is a block diagram for the combinational logic circuit, right? So we don't have any feedback path. So we have a combinational logic circuit where you have a logic gates and input variables and output variables. So whenever you give an input to the logic gates, so the logic gates will accept an input signals and generate an output with respect to the present input. Okay. So you can take any example of the combinational circuit. So here I have taken just a simple example for the combinational logic circuit, right? So this is about a combinational logic circuit. Now, so we have a logic circuit here, right? So this circuit is represented by an expression called Boolean expression, right? Here I have an input variables as A, B, C. So we will just write an expression for this circuit, right? So I'll start tracing from the left hand side. So the output of the AND gate will be AB. Then the output of NOT gate is C bar, right? Then the input to the OR gate is AB and C bar. So the output will be AB plus C bar. Therefore, we have an inverter. So the output will be AB plus C bar the whole bar. So what is that AB plus C bar the whole bar? Is an expression or a function, Boolean function for a given logic circuit. So this expression, so whatever we are getting the expression for the logic circuit, it may be of two types. One will be a sum of product or it may be a product of sum. Means our Boolean expressions are classified into two types. Sum of product, that is SOP, and second one is product of sum, that is POS, right? So before going to this SOP and POS, we'll just uh, know the what is a product term and the sum term, right? So in the expression, if you see the terms, like if it is a group of literals are ANDed together, right? If I see the any expression like x, y bar, z, so here I have a literals, that is x, y bar, z are the literals which are ANDed together. So this x, y bar, z is an product term, and similarly ABC, right? Then what is sum term? The group of literals ORed together, right? So if I have a literals like x, y bar, z, which is odd, x plus y bar plus z. So that together we call it as a sum term. Okay. So then what is SOP now? So as the name indicates, it is sum of products, right? So it is nothing but the product terms are ORed together. SOP, right? So how we define a sum of product terms? It is a Boolean expression in which the product terms are ORed together, right? So example, uh, f of x, y, z is equals to x, y bar, z plus x bar, z plus x, z. So here we have a three product terms, x, y bar, z, x bar, z and xz are the three product terms which are ORed together. So we can call this uh, expression as a SOP expression. Rather than calling it as generally a Boolean expression, we can call this as an SOP expression. Similarly, we have a product of sum. POS means here the sum terms are ANDed together, right? So it is an Boolean expression in which the sum terms are ANDed together, right? We can take an example here. So f of x, y, z. So x plus y bar plus z is one sum term. X bar plus z is an another sum term and x plus z is an another sum term. So all these sum terms are ANDed together. So we call this as a product of S sum, right? So these are the two types of, right. So we now we came to know about what is SOP and POS. Now we will discuss what is standard SOP and standard POS. or a canonical SOP and canonical POS. Right. A canonical SOP. Right. In SOP expression, we know that we have a product terms. If every product term will have an all the variables either in a complemented and uncomplemented form, such expression we call it as a standard SOP or canonical SOP. Right? How we will define the standard SOP? It is an expression in which all the product terms contain all the variables either in a complemented or uncomplemented form. We'll take an example here, f of xyz, that is on the left hand side, that f of xyz will declare the expression will have a three variables, that is xyz on the right hand side, right? So just see here, we have a three product terms. All the product terms have all the variables, either in a complemented or uncomplemented form. So this expression, we call it as standard SOP. Rather than calling it as SOP, this is an standard SOP. We'll take another example here. So again in this expression, we have three product terms. All the product terms have all the four variables. Right? Similarly, what is standard POS? So in POS, we have a sum terms. If all the sum terms contains all the variables either in a complemented or uncomplemented form, we call that expression as a standard POS or canonical POS. Just take an example here. So if of xyz is equals to x plus y bar plus z, ANDed with x bar plus y plus z, ANDed with x plus y plus z. See, all the sum terms have all the variables, all the three variables in a complemented and uncomplemented form. Similarly, we can take another example here, right? Again, we have three sum terms here. So all the sum terms have all the four variables, right? So this is about a standard SOP and POS. So now after this, so if any expression is given, right? So we have to check whether that expression is in standard form or not. If it is not in a standard form, we have to convert that into a standard form, right? So how to convert that into a standard form? By we can convert that by using the following steps. So steps to convert an SOP to the standard SOP, right? First, whenever the expression is given, we are talking about SOP. So whenever the expression is given, right, see all the product term, right? So if the product term have all the variables, no problem. If any product term, find out a missing literal. So that is the first step. You have to find the missing literal in each product term, if any. So suppose if I take an example of f of xyz is equals to x y bar z plus x bar z plus xy. So first product term have all the variables, no problem with that. But the second and third product term is one variable is missing in that, right? So we will find the missing variable. So in a second product term, y is missing, whereas in a third product term, z is missing. So this is a first step. In a second step, and each product term having a missing literal with a term formed by ORing the literal and its complement. That is, if x is missing, then ANDed with that product term is ANDed with x plus x bar. Right? Similarly, if I take an example of that one previous example, so in second product term y is missing, so I'll take it as y plus y bar, ANDed with y plus y bar. And in third product term z is missing, so we have to AND with z plus z bar. Now By using distributive law, just simplify this, expand the terms. So we will get an expression, right? Just see this expression now. So whether all the product terms have all the variables, right? So this is an standard SOP. So these are the steps to be followed to convert any Boolean expression into a standard expression, right? If it is not in a standard form. We'll take another example here. So convert a given expression in a standard form. So f of ABC is equals to AC plus AB plus BC. So what is my first step, students? So first I have to find out a missing literal, right? So in a first product term, B is missing. In second product term, C is missing. And in third product term, A is missing. Now I have to AND with the terms, right? So for first product term, I have to AND with B plus B bar. And for second, C plus C bar. And for third, A plus A bar. So now we will expand this expression using the distributive law. So then we will get an expression ABC plus AB bar C and ABC plus ABC bar ABC plus A bar BC, right? So, and one more thing you should remember, students. So while writing the expression, the product term, follow the variables in a order how we have represented in the left hand side. Okay, then so this is an standard SOP. Now, so we will go to the steps to convert a POS into a standard POS. So again, same in POS we have a sum term. Okay, so find out a missing literal in each sum term. That is the first step. If I take an example again here, right, x plus y bar plus z ANDed with x plus x bar plus z ANDed with x plus y. So the first sum term have all the variables, but in second and third, one variable is missing. So in a second, y is missing, and in the third sum term, z is missing, right? So this is a first step. Then, or each product term having a missing literal with a term formed by ANDing the literal and its complement. For example, if x is missing, then you have to OR with the sum term with x plus x bar, right? We will do that now. So in the second term, sum term, y is missing, so I will OR with y plus y bar, whereas in the third sum term, z is missing, so I will OR with z plus z bar. Again, we will simplify this expression, right, using distributive law. So I will get an expression that is x plus y bar plus z, x bar y plus z, x bar plus y bar plus z, then x plus y plus z, then x plus y plus z bar. So this is, just observe the expression here, whether all the product terms, sorry, all the sum terms have all the variables, then it is an standard POS. We will take another example here. A, B, C, D is equals to A plus B plus C, and A ANDed with A plus B plus C ANDed with B plus C plus D. So first we will find out the missing literal in each sum term, right? In first sum term, B is missing. In second sum term, D is missing. And in third sum term, A is missing. So we will OR with a variable in each sum term. For a first sum term, we will OR with B ANDed with B bar. Then for the second sum term, we will OR with D ANDed with D bar, and for third, A ANDed with A bar, right? So now we will expand this expression using distributive law. So we will get A plus B plus C plus D, A plus B bar plus C plus D, A plus B plus C plus D, A plus B plus C plus D bar, and A plus B plus C plus D, and A bar plus B plus C plus D. So here you can remove the repeated terms. So the final expression we will get is this one, right? So check all the sum terms have all the variables, then this is an standard POS expression. Okay, so this is how we will convert any given expression, either it may be a SOP or POS, into an standard form, right? So once you bring this in a standard form, we have a sum term and the product term. This sum term and product term, we call it as a min terms and the max term, right? So then what is a min term and the max term? So in a standard SOP, we have one product terms. That individual product term, we call it as a min term. Whereas in a example, f of ABC, so ABC, A, B bar C, all these, each product term, we call it as a min term. And so max term is the individual sum term in a standard POS is called a max term. So we will take an example here. So we have three sum terms here. So each individual sum term we call it as a standard, max terms, right? So this max terms and min terms are represented. In order to represent that Boolean expression in a shorthand notation, we will represent a min terms and max term using this table, right? So if the variables is A bar, B bar, C bar, so we will write that as M0. If your sum term is A plus B plus C, so that is, we will write it as M0. So the min terms are represented with a small m with a suffix I, whereas a max term is represented with a capital M, right? And in a min terms, the uncomplemented are treated as 1 and complemented as 0. Whereas in a max term, the uncomplimented as 0 and complemented as 1. Okay, so in a shorthand notation, the min terms, that is, we will represent with a summation of m, whereas a max term we will represent it with a pi m, right? So now in the previous problems, we have just brought that given expression in a standard form. So those expressions we need to represent in a shorthand notations, that is in a canonical form. So how to convert that in canonical forms, right? So we will take an example here. So if the given expression is in the standard form, so I have an expression here, f of a, b, c, right? So see, the all the product terms have all the variables, so it is in a standard form, that is standard SOP, right? As already told you, standard SOP means each product term we call this as a min term. In min terms, the complemented is 0 and uncomplemented is 1, right? So we will give just a numbers here. So here all are uncomplimented, so 111, here 101 and 110, 011, right? So how we will represent this in a min terms? So this is what is a decimal notation for 1117, right? So we will represent that as M7. Similarly, decimal value of 101 is 5. So M5, M6 and M3, right? So we will write this as summation of M and take all the min terms in a bracket, right? 3, 6, 5, 7. It is the in the canonical form. So now we will take another example here. So this is an standard POS, right? So all the sum terms have all the variables. Okay. In a standard POS, each sum term we call it as a max term. Here, the complemented is 1 and uncomplemented is 0, right? We will just take, so here in the first sum term, all are uncomplemented, so 000, and here it is 001 and 010. So together we can write it as M0, M1, M2, right? So we can represent this as pi of M0, 1, 2. So this is the canonical form, right? So we'll take one or two examples how to convert a expression in a canonical form, right? So take an example here. So convert a given expression in a canonical form. So f of ABC is equals to AC plus A bar B plus BC bar, right? So first we have to check whether it is SOP or POS. So it is an SOP expression and it is not in a standard form. So we need to bring this in a standard form, right? How to bring this in a standard form? So first we will find out the missing literal in each product terms, right? So here in the first, the B was missing, so I will end with B plus B bar. And in the second one, C is missing, so we will end with C plus C bar. And in third one, A is missing, so we will end with A plus A bar, right? And expand the terms using distributive law. So we will get this term, right? ABC plus A B bar C plus A bar B C plus A bar B C bar plus A B C bar plus A bar B C bar, right? As I already told you, while writing the product term, please follow the sequence what is represented on the left hand side, right? We have followed ABC sequence over there on the left hand side. So please, all the product terms should be there in a same sequence. It should be in a same sequence, right? So now it will be a 111, right? 101, 011, 010, 110, 010, right? So we will write them in terms as M7, M5, M3, M2, M6, M2, right? So repeated min terms, you can take it at a single time, right? So we can write this as summation of M 2, 3, 6, 5, 7. Okay. Similarly, we can take another example here.